Thank you. Thank you for your good introducing. It looks like this room is like a family meeting, so I'm very glad to be here. Okay. As she told, the title today, my presentation is Onion Waste Recycling to Produce the Value-Added Byproduct. This is my name. My name is Hyeun Jong Bae. I'm from South Korea. Actually, this is Korea, and this is our traditional clothes, buildings, our traditional foods, and this is our traditional music. It's named the K-pop, so it's very popular in the world. This is our university. This is our campus as for the four seasons. So this is spring, summer, fall, and winter. We have very beautiful campus. I'm the director of the Bioenergy Research Center in Jeonnam National University. Actually, our research center is got a good program named the Priority Research Center from 2010 until 2019. So we're supporting from the KRF program, Korea government supported $5 million project for them. Our research center is nearly on focus on the biotechnology. It's our key component of bio research center. We want to value high value creation in the biomass, but process of bioconversion. We want to developing the very good pretreatment for the biomass, and we also developed the enzymatic process for the biomass bioconversion. Also, we developed a lot of some advanced biotechnology to create some kind of new value-added material from the biomass. Actually, onion is the very popular food resource for all of the world, especially in Asia. The onion is very important food resource. But also the onion waste is produced from the various processed onion. Because they are one of the major industrial waste material and one of the big problem in Korea and many countries. So we are really focused on how can solving this problem. So our Bioenergy Research Center pioneering following issues. We want an environmental friendly method to handle waste material. Also, we want to do the cost reduction of waste treatment. We would like to designing to agricultural waste recycling. We want to find the new waste value-added material production. This is our kind of some targeting objective. All over the world, onion is produced quite a huge amount of the onion is produced. Around 83 million tons of onion is produced annually. That's the 2013 data. And China and India, they are kind of major producing country. And Korea also, we produced around 1.1 million tons. This is pretty much similar numbers with Spain. Even though the two countries, like China and India, is a major main producing countries, but especially the Korea and Japan, Europe and United States, the high yield are found in Korea and Japan and Europe and the US. By meaning, the density production we are very high. For example, you can see the numbers per tons of hectare. In South Korea, some area they produced huge 66 tons of each hectare. So that's the density production. Density is pretty much high numbers. And I'm from the Jeonnam areas. So the Jeonnam area in Korea, we produce around 20 to 30% of onion. So we are very high production area of the South Korea. Actually, our Bioenergy Research Center, we have developing the enzyme technology. So in the point of enzyme biotechnology, for the degradation of the lignocellulose, many enzyme cocktail is necessary. Lignocellulose is a multi-complex polymer. So to break down the lignocellulose, we also need the multi-complex enzyme cocktails. For example, to break down the cellulose, we need some kind of endocellulase. They can randomly attack the cellulose chains. Another, some cellulose hydrolyzed enzymes, they can attack the cellulose chain ending point, produce the cellulose. Then this cellulose can be broken down by beta-glucosidase. Recently, another name of the enzyme, GH61, another name is AA9 enzymes, they can attack the crystalline of the cellulose, such like that. Many enzyme cocktails, many enzyme composition is very important to break down the lignocellulose. We have been developing this technology more than 10 years. Then, also we have tried to increase the enzyme activity, and the mass production is we're working for the enzyme production. Right now, our research center have around 500 liters of the pilot plant to produce the many multi-enzyme systems. So we want to apply this technology to the solving this kind of anion waste materials. This is very good example for in this slide. You can see that this is anion waste materials. We applied our enzyme cocktail to this anion waste. We can make the like in 12 hours. We can completely break down the anion waste. Right now, if we good combination, we can make it around 6 hours. Completely can make the degradation of anion skin waste, and also, that means we can, enzymatic process, we can produce anion juice, sugar juice. The processes we can explain like that ways. Anion skin waste can be applied enzymatic hydrolysis, then anion produced, the anion sugar juice is produced, and this anion sugar juices is very easily can fermentation to produce the bioethanol. So this is kind of some one theory of our applying process. We want to add more theory, more the value added process. We evaluated the use of the anion skin waste for biosugar production, for the bioethanol, and also quercetin production. Quercetin is kind of the flavonoid bioactive materials. So if we do this kind of anion skin waste hydrolysis, we can produce bioethanol, and also we can produce quercetin, which is a very good value-added material. Quercetin is kind of flavonoid, and this price is nearly good price in the market already. And this price is nearly depend on the purity. So we developed our technology to make the good quercetin extraction and purify. This is chemical composition of the anion skin waste. You can see that there's quite a high amount of the glucose content, almost the dry weight, almost the 40% of the glucose is in there. Also, they got total sugars is 53%. Of course, there is some galactose, mannose, xylose, arabinose, lamnose, but their sugar content is still pretty much high content. This is nearly good candidate for the producer of the bioethanol. Another chemical composition is they got some quercetin. The anion skin, they have the very good quantity of quercetin. Quercetin is they got around 0.1 to 0.2% in the skin of the anion. We tried to make the good enzyme application to break down the anion skin waste. So you can see that we applied the pectinase, we applied the cellulase, we applied the gyalanase. With some good combination numbers, we can produce the biosugar conversion rate close to the 90%. So we try to make some optimize which enzyme cocktail is best enzyme cocktail to break down the anion skins. Our targeting is we want to make the close to the 90% numbers with as much as we can, no loading of the enzymes. So we can make the very good enzyme cocktails produce 90% of the bioconversion, produce the biosugars. This is data of when we applied our enzyme cocktail to the hydrolysis of the anion waste. You can see that most of the data produced sugar is glucose, and the conversion rate is close to over the 90%. Also, they produce the xylose sugar too, close to the 70%. After that, we using this kind of the hydrojet after enzymatic hydrolysis. We applied some technique to analyze the TLC method to show how much of quercetin can be existing in the skin waste. This is figure 1, explain the very good data. This is standard control of quercetin. Before hydrolysis, quercetin extraction is this amount of quercetin is come out. But after enzymatic hydrolysis, you can see that quercetin produced amount is pretty much increased. So we analyze HPLC. This is kind of some before hydrolysis, quercetin extraction. And after enzymatic hydrolysis, quercetin production is much higher. When we quantified, we can produce almost 1.6 times quercetin can be extraction from this hydrojet. That means if we applied this enzyme technology to the onion skin waste, we can produce more quercetin from the onion skins. Also, we applied some nanotechnology. This nanotechnology theory is like this. We can make some kind of the biomagnetic of the separation technique. We make some kind of nanoparticles, silica coated with magnetic nanoparticles. Then we added the terpidin receptor is binding with this nanoparticle binding with the terpidin, we named the TSMMP. Then this terpinidin TSMMP can binding with the zinc. And the zinc is very effectively binding to the quercetin. Selectively, they can affinity with quercetin. After that, we can very easily separate this quercetin. So if this kind of nanotechnology is applied, this means we are very selectively purify the quercetin from the hydrojet. This is very useful ways, and also this nanoparticle can be reusable many times. We tested 20 times, we can reuse it continuously. So very easily can purify the quercetin from the waste hydrojet. So this is a theoretical kind of mass balance. If we can here test the 10 tons of the onion skin waste, we can produce around, of course this is solid base data. We can produce 800 kilograms of glucose, and we can produce around 20 to 32 kilograms of the quercetin. After that, we can produce around 370, if the conversion rate is over the 90%, we can produce the 370 kilograms of the ethanol. Also, we can produce the quercetin 21.6 kilograms. So this is, I believe that from the waste, onion waste material, if we can produce like this kind of very expensive quercetin, expensive the ethanol can be produced. This is very the useful theory for the application for the waste materials. Okay, thank you for your attention. This is my research groups. And any questions?
Yeah, thank you for this presentation. I'm interested on the use you will be doing with this ethanol and kerosene you are producing. Is it for market? Is it for what kind of use would that be? And how could you have a kind of market for that?
In the case of quercetin is already in the commercial market. The price is very different depend on the purity. For example, 95% of purity quercetin price is like $100. But if the purity is 96%, 97%, the price is twice. And we can, if you're using nanotechnology, we can purify the quercetin close to the 98% of purity. This is best price, almost $300 per kilogram. So we can make a very good product from the onion waste. Another point is bioethanol we can get from the quercetin because they have the very good biosugar content. If somebody working for some chemical engineering process, the quercetin biosugar have the very, very good sugar content. That means another name of the biosugar market can be created from this waste material. So the potential is pretty much higher compared to any kind of the biomass material. Thank you.
Excuse me, I wanted to ask you, onions have also some other really good substances. Have you tried, apart from quercetin, any of the other possibilities of?
Actually, we try to produce some low sugar from the onion waste sugar, onion biosugar. But this is very high technology to apply for the low sugars. But this is kind of new market already in Japan. They have the very good new market of the low sugar. Have you ever heard the cycles?
Well, I was more thinking of the sulfur substances they contain. I mean, in Spain they are very famous because they have certain substances that are very good for you, especially sulfur-containing substances is what comes to my...
I know the market. The problem is actually the final product cost is pretty much compared to the quercetin or something like that. They are very low. But this is very high priced value-added materials. So it's probably can recreate the kind of new market from the waste materials. That's what I think.
Okay, so what you mean is that the market for quercetin is a lot of money compared to this other...
Sure.
Possible. And you get to a pilot plant scale with this kind of nanotechnology?
Right now we just got a 500 liters pilot scales.
Mm-hmm.
But this is pilot. We are going to maybe ton size of the factory scales.
Okay, so comparing these other substances with sulfur, with quercetin, really there is not much market. I mean, it's much... You get much more money of the quercetin than of the others, I suppose.
I expect.
That's what you mean.
I expect.
Okay, but the others are very good as well. I mean, as far as I remember...
Of course, I believe that. But other markets are already mature. But this is new market, so you know, yeah.
Okay,
thank you.
No, what I mean is that perhaps you could have like several scenarios where you could have the quercetin as well as the others, as well as the... As the bioethanol.
So one of the big problem is actually onion waste is nearly serious problem for the waste market, waste areas. You know, it is not well degraded in the ground. You know, it is very difficult. The smell is nearly bad. So people really right now just dump them on the ground, but they are very difficult to handling. Mm-hmm. So if we can apply this kind of technology, we can create the new market with the very good handling of the waste materials. That's our strategy.
Mm-hmm. Thank you.
Thank you.